binary operator. So we can overload any operator. There are certain assumptions are there that we will see later also. Now we let us see how to overload a binary operator. Binary operator means what? An operator that requires two operands. That requires two operands is called a binary operator. Binary operator. So now in this case, what we will try to do here, we will try to add the contents of two objects. Contents of two objects. Okay. So generally, operator what it will do? It will add two numbers. It will add two numbers. Got it? But here what we'll do? We'll try to do the work in such a way the objects are getting added. The values of the objects are getting added here. Okay, so now we can see that. So this is in the line number 4 we have a class declaration. In the class declaration we have the class name as overload binary. Overload binary, OB binary is the class name, and it has data members x and y. Okay, x and y. Okay, by look at the program at a glance, probably might that this time you might have come to the conclusion. It's an addition of complex numbers, addition of two complex numbers. Okay, so now here what we will have here, see, as I told you, you can have your functions, member functions, or whatever you call. It can be placed either inside the class or outside the class, anywhere else you can. But here it is declared inside the class. So what is the principle here? So first we have an operator function. In an operator function, we have using the specifying the keyword operator. Then the operator that's going to be overloaded. Okay, what is that operator to be overloaded is plus. And also, since we are going to deal with an objects, okay, objects on both the sides. So what do we have? We use one object. We use one object called object 1 of this class of OB bin. Now if you look into it, okay, I just wanted to tell you guys. So here if you have, let's say, one object, okay, so what is that object name? It is OVB OVOBJ1. Got it? So now this OBJ1, overloading object 1, overloading binary object 1 will have two member function now, x and y, x and y. Then also inside you can see that temporarily and another object is being used. So for this also we will have an implementation where it is an overloading object binary, overloading binary operator. Okay, it's 2. Now this 2 also will have the value of x and y. Okay, we'll have two data members x and y. So here how the work is done, the operator plus operator is being used in a way that, got it, x, one, there will be one calling object, there will be one calling object. Okay, let's say the calling object is what to say, I'll see the main program. The calling object here is main OBJ4, and okay, so we will call it as 4, 1 is 5 and 4. Okay, so we'll make it as object 5. Calling object is object 5. Object 5. Now this object 5 also will have x and y, x and y. So now how the program is written, okay, so this x will be added with this x. Okay, similarly this y will be added with this y. Okay, These two are addition. So now the result of this x, the result of this x will be given to this x, and the result of this y will be given to y of object 2, y of object 2. That's a basic concept here. So when it comes out, we will be getting only one object called object 2, OV object 2. Understand? Okay. So now x plus obj1.1 x the y, and this object is going to be written. This object will have the written value over here. Okay. So next, what do we have? We have a display function. Display function is just to represent the x and y value in the form of complex numbers. You know that a plus jb, right? A plus jb. So to display the numbers in a complex format, so we use this member function. We use this member function. Okay. Now coming to this another thing. Okay, it's a constructor. It's a constructor. OVBin is a constructor. You can see that. What the class name? OVBin. Okay. So now here, if you look into it, this is also an OVBin, isn't it? So OVBin, we having two data members, right? So those two data members are going to be initialized with the value of a and b through this member function, through this constructor. Then also this is a default constructor. This is a default constructor wherein no arguments are passed. So x and y are going to be initialized with the value y 0 for y, 0 for x, and 0 for y. Okay. So now if you look into it here, what happens? So the main program is there, and in the main program we create an object. So one object is created called object 4. Okay, object 4 is having two arguments. Object 4 is going to be two arguments. So this will be going for x, and this will be the y. This will be y. Then here this OVBin, okay, will be having another object called object 5, and this will be the x value, and this will be the y value. This will be the y value. And now if you look into it, there is another object we are declared here called OV object 6. So the sixth object will be the one which is going to hold a result. So what do? We just pass the objects here. Okay, instead of passing the variables, now you are passing the objects. Okay, as you pass the object, so one of these objects will be acting as an argument for the member function implicitly. Another object will be directly used into the functions as an argument. Okay, so these two objects will get added, and each object will get added. No, the member function of x, the data members x and y of each object will get added here, and as it gets added here, then the object will be returned through 6, object 6. Okay, so that will give us the addition of two complex number values. Okay, and also you can see that I'm using a display objects to display what is that object value for x and y values, what is that x and y values of object 5, and what is the value of object 6 x and y values. Okay, I just wanted to put it in the frame where you can see that the complex numbers are getting added over here, isn't it? So when how do you do that? Add the complex numbers. You will add the imaginary part separately, you will add the real part separately, and you will display it in a way that it's going to be executed like complex number addition. Okay, so now let's execute this program and check it out. So here what are the numbers are given for x and y? 2.5 and 5.5, 7.5 and 3.3. These are the two complex numbers. This is in the real part, this is imaginary part. Real part and imaginary part. Okay, so hope the things are open here. Yeah, so here we got overloading binary operator. So already we have discussed the program. I'm just running the program now. As I run the program, okay, we can find that everything is hard coded here. I'm not taking any value from the user at this point. Okay, so as I not taking the user, value from the user, then it can straight away execute the program. Okay, you can see that here. Okay, so two complex numbers are getting added. Imaginary parts are added here. 5.5 plus 3.3, it is 8.8. And here, if we look into it, real part is gets added here. 5, 5, 0 and 1. Then 7 plus 2, 9, 9 plus 1, 10. So 10 plus j, 8.8 will be the addition of two complex numbers values. Okay. So how we have done? We have done this with the concept of operator overloading. Now the plus operator is capable of adding two complex numbers. Plus operator is capable of adding two complex numbers, and how it is overloaded? It's overloaded in a way that it can add the contents of the objects. Okay, contents of two different objects. Understand? Otherwise, it should be only a single number. But here we have empowered the operator to add two different objects.